All right, I'd like to make a couple of observations about 4.2a, which is linear and quadratic functions. First of all, let me make a distinction between linear and quadratic functions. A linear function is a function of first degree. What that means is the largest exponent is 1, x to the first power. A good example of which might be f of x equals 2x plus 3. Notice exponent of 1, largest exponent is 1. Some of you guys are going, hey, that's the slope-intercept form of a line, isn't it? Absolutely is. This linear function is just a function that describes a line, hence the name linear. If I want to find out what it looks like, I'm going to pick some x's and find some y's. So let's let x, for instance, be 0. 2 times 0 is 0. 0 plus 3 is 3. Let's let x be 1. 2 times 1 is 2, plus 3 is 5. Let's let x be 2. 2 times 2 is 4, plus 3 is 7. I got 3 points. All I really needed was 2 because it's a line, right? 0, 3, 1, 5, 2, 7. And there's the picture of this linear function. Graphs into a line. Every single point on that line satisfies the function y equals 2x plus 3, or if you put it in function notation, f of x equals 2x plus 3. Typical linear function, you're basically already familiar with it. Next, we have something called a quadratic function. In this case, the largest exponent is 2. It is a second degree equation. And in standard form, it looks like y equals so many x squareds plus so many x's plus c, a constant number. Or if you put it in function notation, g of x equals the same thing. Most of you know what a quadratic function graphs into, but let's see if we can demonstrate with an example of a quadratic function. Let's see what it graphs into. Here's a very simple quadratic function, x squared plus 3. Notice I don't have any x's. Actually, I do. It's just that the number of x's I have is 0. X squared plus 0x is plus 3. But this is a very simple quadratic function. Once again, I'm going to pick some x's and find out what y is. And when you have a function like that, f of x equals something, and you want to find some points, a much better way to express it is y equals. That way you have your x and your y both visible in the equation. So let's pick some x's, like 0. 0 squared is 0, plus 3 is 3. Let's pick 1. 1 squared is 1. 1 plus 3 is 4. And let's pick a negative number. Negative 1 squared, that means negative 1 times negative 1. That's positive 1 plus 3 is 4. Let's try 2. 2 squared is 4 plus 3 is 7. Let's try negative 2. Negative 2 squared also is 4 plus 3 is 7. So I have enough points, I think, to give me a good picture of what this graph looks like. 0, 3, 1, 4, negative 1, 4, 2, 4, 5, 6, 7, negative 2, 7. And here's where you get the idea. Oh yeah, I remember what a quadratic function looks like. It looks like a parabola. It looks like a U-shape. And one thing you're going to notice about these quadratic functions is the only way they're going to look is either an upward turning parabola or a downward turning parabola. And it all depends on the number in front of your x squared value. For instance, if you have f of x equals negative 3x squared plus 2x plus 5, just made that up, whatever it looks like is going to be a downward turning parabola. Why? Because of the negative 3, the number in front of the x squared. If you had an f of x equals 7x squared minus 9, then whatever it looks like, we'll pick some points and find out what it looks like, it's going to be an upward turning parabola. How do I know it's upward turning? Because the number in front of the x squared is positive. So we have our linear function, simply the graph of a line, and we have our quadratic function, graphs into a upward or downward turning parabola. All right. Hey, notice that if you have a linear function, you can look at your expression and tell some important things about it, right? For instance, the slope of this guy is 2, and the y-intercept is 0, 3. No surprise, y-intercept is 0, 3. So I can look at a linear function like this and tell some important things about it. It's unfortunate, though, I cannot, as this is written, look at a quadratic function and tell where its important value is, that is, its vertex. This is called the vertex of a parabola. It's either its lowest point, or if it's a downward turning parabola, its highest point. It's the point where the graph stops going down and starts going up. Stops going up and starts going down. It's a turning point for the parabola. As this is written, I cannot look at the graph of this and tell what the vertex is. However, there is a form of the quadratic function known as the vertex form. And you're going to see this form multiple times. It goes like this. If f of x is, in parentheses, x minus h squared plus k, then my vertex of this particular parabola is going to be the opposite of this number, h, and exactly that number, k. For instance, if I gave you that and said, what's the vertex? You'd say, well, it's the opposite of this number and exactly that number. And since the number in front of my parentheses is a positive 1, I know this is an upward turning parabola with vertex at the point 7, 3. 7, 3, upward turning parabola. All right, look at another one. What's the vertex of this guy? Well, it's simply the opposite of this number and exactly this number. And since there is a positive in front of my parentheses, I know likewise this is an upward turning parabola. It's got a vertex at negative 4, negative 17, and it's an upward turning parabola. Now, a couple of other things you're going to notice about your Hawk's problems is they will ask you for the vertex, and you go, okay, it's opposite of that and that, opposite of that and that. Then they're going to ask you for y-intercepts. Now, let me show you, let me demonstrate to you that parabolas can have x-intercepts. 2, 1, or 0 x x-intercepts. For instance, this guy right here has one x-intercept. It intersects or touches the x-axis at one point. This guy has two x-intercepts. It intersects the x-axis at two places. It could be downward turning as well and have two x-intercepts. It could be downward turning and have one x-intercept. These two have one x-intercept. These have two. I can also have no x-intercepts. How's that? Like this. These parabolas have no x-intercepts. So when it asks you for x-intercepts, it will say, okay, how many you got? You got one, you got two, or you got three. And we'll show how to, or none. One, two, or none. And we'll show how to find those x-intercepts in just a second when we work some problems. All right, let's work some problems. Excuse me. Here's an example of, it says, a linear function. How do I know it's linear? It's asking me for a slope and a y-intercept. When they ask you for a slope in the y-intercept, hey, it needs to be in the form y equals mx plus b. So what I do to find the slope in the y-intercept is solve for y. So here we go. Now, instead of k of x, I'm going to use y equals. And let's see, 2x minus 19. Apply the negative. Negative of negative 15 is plus 15. Negative of x, negative x. So we get y equals, let's get our x's together. 2x minus x is x. Negative 19 plus 15 minus 4. So I have solved the thing for y. I should be able to find my slope. It's the number in front of x. I don't see a number, must be a 1. And my y-intercept, they want me to put it as a point, so it's 0, negative 4. Slope, y-intercept. So if they ask for the slope in the y-intercept, you solve the thing for y. All right, find two additional points on this particular line. This line, y equals x minus 4. I need two more points. They don't want the y-intercept. They want two additional points. So I got to pick something for my x other than 0. So let me pick 4, for instance. 4 minus 4 is 0. Let me pick 5. 5 minus 4 is 1. I got two additional points. That's all I'd ask for. All right, look at this guy. R of x equals x minus 3 in parentheses squared minus 1. Hey, wait a minute. I'm thinking that's the vertex form. The vertex form of my quadratic function. Here's the x minus h plus k. To find the vertex, remember I do the opposite of this number and exactly that number. So my vertex should be no problem at all. Positive 3, negative 1. Remember, opposite of this number, exactly that number. Got my vertex. Now it says find the x-intercepts. Do you remember what we did to find the x-intercept of a particular line in standard form? We let y equal 0. And that is exactly what we do in any equation to find the x-intercepts. You let y equal 0. So in this function where it says r of x equals something, I don't see a y. Oh yeah, I can always express my function notation in standard form, which is y equals. If I'm going to let y equal 0, I need to have a y in there. So I substitute y for r of x. So let my y equal 0. So 0 equals that. Now I need to solve this guy for x. That means get x by itself, right? So let's add 1 to both sides. I get 1 equals x minus 3 squared. That's the guy I'm looking to get by itself. Right now it's in a parentheses squared. Got an idea of what I can do to both sides? That's right, square root of both sides. Now the square root of something squared is just a something. So square root of x minus 3 squared is just x minus 3. Now watch this. This is where I get my two answers. Here's where I get, here's where it's a little bit subtle. The square root of 1, you go, hey, square root of 1, that's 1. Yeah, well the square root of 1 is actually plus or minus 1. Because positive 1 squared is 1, and negative 1 squared is also 1. So when you take this square root, solving for your x-intercepts, always include the plus or minus. This is two different equations. 1 equals that, and negative 1 equals that. So let's write it as two different equations. First of all, positive 1 equals x minus 3. And secondly, negative 1 equals x minus 3. To get x, I add 3 to both sides. Add 3 to both sides. In this case, I get x is 4. In this case, I get x is 2. Those are my x-intercepts, and they asked me to express them in ordered pair form. So instead of saying my x-intercepts are 4 and 2, which is perfectly legitimate, I'm going to say my x-intercepts are 4, 0, and 2, 0. Hey, I could draw a picture of this guy. I could come up with a good idea about what this guy looks like. I know the vertex. Let's see, the vertex is 3, negative 1. 1, 2, 3, negative 1. And I know it cuts the x-axis. The x-intercepts are 4, 0, and 2, 0. 1, 2, 3, 4, 0, and 2, 0. Hey, there it is. There's what my parabola is going to look like. And I figured it out because I know the vertex and I know the two x-intercepts. All right, it also asked me to find two additional points on the graph. Not these and not that. So let me express my equation, my function, as y equals. And I'm going to get two more points. I'm going to pick an x and find a y. But notice, for my x, I can't use 2, I can't use 3, I can't use 4. Those points are already taken. So let's use 5. 5 minus 3 is 2. 2 squared is 4. 4 minus 1 is 3. Let's use 6. 6 minus 3 is 3. 3 squared is 9. 9 minus 1 is 8. I have two additional points. All right. Make another example. Find the linear function with the following properties. f of 5 equals 1. So whatever this function looks like, when I put 5 in for x, I get 1 out for y. And also I know that this linear function, it's a line, right, has a slope of 5/4. All right, this is kind of subtle. But here's the information that's actually given when it says f of 5 equals 1. It tells me that when I put in the number 5 for x, I get a 1 for y. When I put 5 into the function, it spits out a 1. So what this tells me is I have an ordered pair. The ordered pair is in fact 5, 1. And I know also that the slope is 5/4. Hey, this should look familiar. This looks like scenario number 2 when we were determining how to find the equation of a line when given so much information. I'm given an x, I'm given a y, I'm given an m. All I have to do is substitute into y equals mx plus b and find out the missing variable, namely b. All right, let's see. Y is 1. M is 5/4. X is 5 plus b. So 1 equals, and I could think of 5 as 5/1, so I know how to multiply. 25/4 plus b. All I need to do is subtract 25/4 from both sides. And I'm going to say 1 is the same as 4/4 minus 25/4 equals b. Remember, I just changed 1 into 4/4. So 4/4 minus 25/4, that's negative 21/4 equals b. So I now have my slope, and I've got my y-intercept. I can use that to come up with the equation of the line. Y equals m times x plus b. Find the linear function. So the better way to write it, since it wants me to have it in function notation, is instead of y, I'm going to write it as f of x. Same thing. One's standard notation, one's function notation. And there it is. Once again, f of something equals something else. That gives me an x and a y. As simple as that. The function evaluated at a particular x gives me a particular y. I know a point on this function, 5, 1. I know a slope. Fill in for y equal mx plus b and solve for b. All right, consider the following function. F of x equal x squared plus 7x plus 6, and ask me to find the vertex. Hey, wait a minute. This is not in vertex form. Vertex form is something in parentheses squared plus something else. That's not vertex form. This is in standard form, so I'm going to have to come up with another way to find the vertex. You ready? Here it is. This is ax squared plus bx plus c. So be sure and write it in standard form, the x squareds, the x's, and then the numbers. And go ahead and write down what a, b, and c are. A is the number in front of x squared. I don't see anything. It must be a 1. B is the number in front of x. It's a 7. And c is the number at the end, the constant number. It's a 6. All right, with that information given, I can find the vertex by using this form, minus b over 2a. That's going to be the x value of my vertex, right there, minus b over 2a. So all I have to do to find the vertex, to find the x value of my vertex, is minus, b is 7, a is 1, so 2 times a would be 2. There it is. There's the x value of my vertex. Now, if this was a really easy number like 2, all I would do would be substitute it in for x and find out what the y is. 2 squared plus 7 times 2 plus 6. But this is kind of an ugly number. So I'm going to choose to use another way to find the y value. I'm going to use this form. 4ac minus b squared over 4a. Now that's something you don't want to commit to memory. It's something you want to have handy to be able to find the vertex when the quadratic function is not in vertex form. So let's find the second value, the y value for my vertex. It's 4 times a, which is 1, times c, which is 6, minus b squared. b is 7, so 7 squared is minus 49. All over 4 times a, 4 times 1 is 4. So the x value is negative 7/2. The y value turns out to be, let's see, 6 and 4 is 24 minus 49. I'll go ahead and write that out one more step. 24 minus 49 over 4. So my vertex turns out to be negative 7/2, negative 25 fourths. It's kind of an ugly vertex, but it's doable with this form right here to find the vertex when your equation is not in vertex form. Minus b over 2a for your x value, and then this ratio, this fraction for your y value. All right? Next example, find the x-intercepts, if any. Remember, there may be one x-intercept, there may be 2 x-intercepts, or there might not be any. Let's find out. Remember how to find an x-intercept? Let y equal 0. So, I don't seem to have a y. Oh yeah, that's the same as y. So in the place of my y, I'm going to put 0 equals x squared plus 7x plus 6. Now we got to solve this quadratic equation for x. And what we're going to have to do is factor. Now you and I have not had the factoring section yet, have we? So what we're going to have to do is review ourselves on one concept of factoring. This is just one concept, and then we will do factoring specifically in a whole entire section. But this is where I'm going to ask myself this question. What two numbers multiply to give 6, this number right here, and add to give 7, that number right there? What two numbers multiply to give this number and add to give that number? What numbers multiply to give 6 and add to give 7? Let's see, what multiplies to give 6? 2 times 3, 2 plus 3 is, no, 2 plus 3 doesn't work. 1 times 6 is 6. 1 plus 6 is, yes, that works. 1 and 6 are my numbers that multiply to give 6 and add to give 7. So they go right here. And my two binomials, my two factors are x plus 1 and x plus 6. I set each of these values equal to 0 and solve them. X plus 1 is 0. X plus 6 is 0. That means x is either -1 or x is -6. Find the x-intercepts. They want me to put it in ordered pair form. So my two x-intercepts are -1, 0 and -6, 0. Take heart, the factoring that you'll be asked to do is basically this simple. What two numbers multiply to give that, add to give that. All right, let's consider one last problem. Consider the following function. Find the vertex. Hey, note, this is in vertex form. Vertex form looks like this. That's what we got right here. So my vertex is simply the opposite of this number and exactly that number. Hey, that was pretty easy. So just take the opposite of this number and that number, and I got my vertex. Find the x-intercepts if you got any. Remember to find an x-intercept? Let y equal 0. So in the form of a of x, I'm going to put y equals x minus 3 squared minus 2. And I'm going to let my y equal 0. Now I got to solve this thing for x. We're going to do it very similar to that first one we did. Get the part with the x by itself. So I'm going to add 2 to both sides. I'm going to get 2 equals x minus 3 squared. Remember what we're going to do to get rid of that square? Square root of both sides. Square root of x minus 3 squared is just x minus 3. Hey, don't forget, when I take the square root of 2, it turns into a plus or minus expression. Plus or minus square root of 2. Two different answers. That means that this particular parabola is going to have 2 x-intercepts. Let me express this in 2 different equations. X minus 3 equals plus or minus square root of 2, so either one of those things. So I have to express it in 2 ways. Either square root of 2 equals x minus 3, or negative square root of 2 equals x minus 3. Got to get x by itself, so let's add 3 to both sides. And I get x is 3 plus the square root of 2. That's my first value. And x is 3 minus the square root of 2. Now they're going to ask for the x-intercepts in ordered pair form. So I'm going to write it like this. Here's my x value. 3 plus square root of 2. My y value is always going to be 0. And 3 minus square root of 2. 0. All right, I hope these examples allow you to work diligently on your 4.2a homework assignment. Good luck.